Lesson 1, Day 2, Graphs of Linear Piecewise Functions. Today we're going to sketch linear piecewise functions from a real-life story. Okay, example 4, Marie needed to run a few errands this morning. She decided to stop at Target first since it's on her way to Macy's. Marie left her house at 10 o'clock and traveled to Target, which is 3 miles away from her house. She arrives at 10:12 and stays there for 9 minutes. Marie leaves Target and heads to Macy's, which is 2.5 miles. She arrives at Macy's at 10:33 and stays for 15 minutes. Draw a picture to represent Target and Macy's in location with respect to her house. Okay, so each time you do one of these types of problems, the first thing you're going to do is you're going to draw a picture like I'm about to show you right here. In this particular situation, we've got Marie's house and then Target and then Macy's, and they're all kind of in a row. Okay, so I'm going to start here with her house. Actually, since that's the starting point, I'm going to use like a star. This is her house, okay? And then we've got Target, and then we've got Macy's is where she ends up. Okay, she leaves her house at 10 o'clock. And she travels 3 miles to get to, 3 miles to get to Target. So you want to keep track of the times and the distances because that's what the whole graph is going to be about later on. So it's 10 o'clock when she leaves, it's 3 miles. She ends up at Target at 10:12. And then she stays there for 9 minutes. Now when you say 10:12, 10 o'clock is the hour and 12 is the minutes. So she's going to stay there for 9 minutes. So I'm going to add those 9 minutes onto the 12 minutes to figure out what time she's going to leave. Okay, so 12 plus 9 is 21. So she's going to leave at 10:21. Okay, Marie leaves Target and she heads to Macy's, which is 2.5 miles away. Okay, so she's leaving to Macy's, and Macy's is 2.5 miles away. And she arrives at Macy's at 10:33. And she stays at Macy's for 15 minutes. Again, the 33 would be the minutes, so I'm going to add 15 onto that, and that's going to tell us that she stays there until 10:48. Okay, so that's what the kind of like a linear picture looks like. Linear, remember, means a line. Now we're going to actually draw it in a coordinate plane, using x and y. So on our graph down here, on the x-axis, we have the time after 10 o'clock. So for example, if you said the 6 right here, the 6 would be 10:06. And then on the y-axis, this is the distance that she is away from her house. Okay, so everything's about how far away from her house she is and what time is it. So she starts at her house. So that's going to be our first point, at her house, and it's at 10 o'clock. Now I want you to make sure you label every point. So this point is at her house, and it's 10 o'clock. Then she travels 3 miles, and she arrives at Target at 10:12. So on the x-axis, I'm going to go down to 12. That represents 10:12. And then I'm going to go up to 3 for 3 miles away from her house. So that point represents Target. And it's 10:12. And she's 3 miles away. Oops. I'm going to give myself a little bit more room here. I'm going to write 3 things down. So Target, it's 10:12, and she's 3 miles away from her house. Okay, and then I'm going to connect those points with an ascending line going up. Remember, when a line goes up, that means that time is going forward and the distance is going forward. Okay, so next, she's going to stay at target, which means that the distance is not changing, but the time, remember, time is always going forward. And she's going to stay at target until 10:21. So I'm going to go on the x-axis down to 21, and then still go up to 3. Because she's still at target, she's getting ready to leave. It's now 10:21, and she's still 3 miles away from her house. Okay, so that's a constant line. Now she's going to leave Target, and she's going to go to Macy's, and that's 2.5 miles away. So she's at 3 miles away from her house, and she's going to go 2.5 miles further away from her house. That's going to be a total of 5.5 miles. Okay, so that's that extra piece of information that wasn't in the story that I had to figure out so that I could continue with my graph. Okay, so at 10:33, so I'm going to go down to 33 on my graph. She's going to end up at Macy's, and she's going to be a total distance of 5.5 miles away from her house. So 33 is between 32 and 34, and I'm going to go up to 5.5. So that's right there. Okay, so connect that. So this is when she ends up at Macy's at 10:33, and she's now 5.5 miles away from her house. Okay, and then they tell us that she stays there for 15 minutes, which would take us to 10:48, but we can't actually see 10:48 on our graph, so I'm just going to make a constant line that goes on. Okay? Let's answer some questions about this. Okay, if we did everything correct on our graph, we should actually have our questions already answered. It's just a matter of looking for the right information. First question is, how far is Marie house away from Macy's? And that's the first thing we already figured out. It's 5.5 miles away. Okay, we had to figure that out because it was 2.5 miles away from Target, and Target was 3 miles away from her house, so a total of 5.5 miles. Next question says, if Marie goes straight home after running her errands, how many miles in total, would she have traveled for the day? Well, it took her 5.5 miles, or she was 5.5 miles away from her house to begin with, or to go all the way to Macy's, and it's going to be 5.5 miles to go back home. So in total, that's going to be 11 miles. All right, we're moving on to number 5 now, and this one's a little bit different, and it's actually a little bit harder. So really pay close attention to this one. Billy works for MJR on the weekends. Before he gets to work, he wants to stop and get coffee at Tim Hortons. Tim Hortons is to the west or to the left of his house, and MJR is to the east or the right of his house. Billy leaves his house at 8 o'clock and travels to Tim Hortons, which is 1.5 miles away from his house. He arrives at 8:08, but he can't find his wallet, and he spends 5 minutes searching his car for it. He realizes he doesn't have enough time to go back home, get his wallet, and then still get coffee, meaning going back to Tim Hortons, getting coffee, and then going to work. So he decides just to go back to work. Billy arrives at MJR at 8:35, which is 4 miles from Tim Hortons. Okay, so the gist of it is that, first of all, if you don't know west and east, it doesn't matter. The whole idea is that Tim Hortons is on one side of his house and MJR is on the other. So his house is in the middle of the two. So that's one thing that's different about this story and makes it harder. Oops. So yeah, his house is right here, and that's the starting point, okay? And then we've got Tim Hortons over here, and MJR over here. So they're on different sides. technically it wouldn't matter which side you started, but they did tell us left and right, so I put them that way. All right, so now let's get all of our times in. You're going to find this problem, we have a lot of extra little things that we have to figure out. Anytime, well, this is, I haven't said it yet, but this is a backtracking story. So it's going to be a little different. Billy leaves his house at 8 o'clock. Okay, so they told us that. And he travels to Tim Hortons. So we're going from here to Tim Hortons, which is 1.5 miles away. And he gets there at 8:08. And he spends 5 minutes searching his car while he's there. So this is 5 more minutes on to the 8:08. So he's going to end up leaving there. 8 plus 5 is 13. He's going to end up leaving at 8:13. And then he's going to go from Tim Hortons to MJR. So when he goes from Tim Hortons to MJR, he's going to pass his house. When we make our graph later on, we're going to be looking at the distance away from his house, but he's going to be going now back toward his house. So he's backtracking. Okay, he's going back toward his house initially. So in here, we're going to need an extra point because this 1.5 miles right here, the distance from Tim Hortons back to his house is still 1.5 miles. That 1.5 miles is a different type of 1.5 miles when we go later on to make our actual X and Y graph. Because the first 1.5 miles is going away from his house, and the next 1.5 miles is actually going back toward his house. Okay, but what did they tell us from Tim Hortons to MJR? They told us that that total distance is 4 miles. Okay, so this whole distance here is 4 miles. Okay, now we know it's 1.5 miles going back toward his house. Now what we need to also figure out is how far is it from his house to MJR. So that's the first calculation we have to figure out that they didn't tell us. So I'm going to take my 4 miles and subtract 1.5 miles to figure out how far is it from his house, because then he'll be going back away from his house again. And that's 2.5 miles. Okay, so there's another 2.5 miles here. And that's going away from his house. Okay, so 1.5 and 2.5 does add up to 4. Okay, continuing with the story, what time does he end up at MJR? 8:35. And did they tell us how long he stays there? No, they didn't. But he's going there to work, so I'm going to assume he's going to stay there for quite a while. Okay, so a couple things that we had to figure out that they didn't tell us. They told us the 4, but they didn't tell us that we have to split that up. So that's one thing we had to figure out. Oh, another thing that we're going to have to figure out is what time does he pass his house on the way back? Let's see. Well, if he went from his house to Tim Hortons and it took 8 minutes, because it was 8 o'clock and he got there at 8:08, it's going to take him 8 minutes to go back to his house. So I'm going to take my 8:13 here and add another 8 minutes onto that to figure out what time he's going to pass his house. And that's going to be 8:21. So that's something else they didn't tell us that we had to figure out. It's going to be 8:21 at the time that he passes his house. Okay, so that's something else we had to figure out. All right, I think we now have enough information. All this extra stuff that we figure out always happens whenever somebody backtracks past their house. Okay, we're ready to put this on the graph. Again, the bottom axis is the time, in this case after 8 o'clock, and this is the distance from the house. The y-axis is the distance from the house. All right, so we started at his house at 8 o'clock. So this is his house at 8. And he's going to travel now 1.5 miles to get to Tim Hortons. He ends up there at 8:08. So I'm going to go down to 8:08, so 8 on the x-axis, and 1.5 up for 1.5 miles away from his house. That goes with an ascending line. So that's going to be Tim Hortons, 8:08, and he's 1.5 miles away. Okay, he stays there for 5 minutes, which takes us to 8:13. So I'm going to go down to 13, and he's at the same distance, so still 1.5 miles up. Okay, so he's still at Tim Hortons. It's now 8:13, and he's still 1.5 miles away from his house. Now he's going to leave and go 1.5 miles toward his house. When they go back toward something that they've already left, you're going to have a descending line. So this is our first descending line in this one. And he's going to end up back by his house, or in front of his house, at 8:21. So I'm going to go down to 21. And when he gets back at his house, the distance will be 0. Okay, so this line goes down. So now he's back at his house again. It's 8:21, and the distance is 0. Okay, because he's now in front of his house. Now he's going to go to MJR. He's going to get there at 8:35, so put down 35 on my graph, 35 on the X, and he's going to be 2.5 miles away from his house. So another ascending line. So now this one's MJR. It's 8:35, and he's now 2.5 miles away from his house. And they didn't tell us what happens after that point, but we're going to assume he stays at work. Because he's going to work. He's going to stay there for several hours. Most places you have to stay a minimum of 2 hours. Okay, so now some questions. Again, if we did all of our information correctly, we probably already answered these. And the first question is, how far is Billy's house from MJR? And that's the 2.5 miles. Next question, if while driving to work, Billy decided to get his wallet, what time would it be? That's the 8:21 I already figured out. That's the time that he passes his house. And then lastly, if Billy went straight home after work, how many miles did he travel in total? Well, it was 1.5 miles from his house to Tim Hortons, and then 1.5 miles that he backtracked back toward his house, 2.5 miles to go to MJR, and assuming he went straight back home from work, from MJR to his house, it'd be another 2.5 miles. Grab your calculator and add it up. 8 miles altogether. That is using a time distance graph. So the only time that you backtrack or go back toward your starting point, that's when you would have a descending line. It's a little different than the elevation graphs. The elevation, you can kind of tell a lot better because they say something is going down, whereas distance, you actually have to be going back towards your starting point.